Now we will show you the processing steps for electron microscopy. There are some differences in the preparation. The basic concept is the same. First, we are taking the sample and doing what we call the grossing, which means getting smaller sections of our sample to do the processing one. Note that the samples we are taking, the sections are extremely small. We will place the sample and the fixative again in glutaraldehyde. And leave it in glutaraldehyde for 2 days. Remember that glutaraldehyde is a more powerful fixative material. This is why we use it with electron microscopy. Now we will remove the glutaraldehyde after 2 days of fixation. Discard the glutaraldehyde. And we will put osmium tetroxide as a post-fixative material. Remember, the osmium is toxic, so this has to be done within the fume hood. Now we'll remove the osmium tetroxide from our sample. Remember to discard the osmium tetroxide in a safe container because it's toxic material. The next step would be to wash our sample with phosphate buffered saline. So we are washing using phosphate buffered saline or PBS. And we usually do more than one step of washing. Now we will do the dehydration step. We will start with 70% ethanol. First we remove the PBS, put 70% ethanol, leave it for 10 minutes, and then remove it again after the 10 minutes. Replace it with 100% ethanol. Leave it for 10 minutes and repeat the final step again. So we remove the 100% ethanol and replace it with fresh 100% ethanol again. We will now remove the 100% ethanol and replace it with propylene oxide. Note that the propylene oxide is light sensitive, so we keep the material shielded from light. This step will be repeated twice, each time leaving the material for 15 minutes. Now we will remove the propylene oxide and replace it with a mixture of propylene oxide and resin, 1:1. This mixture will be left for 1 hour. This is the mixture of propylene oxide and resin. We put it on the sample and leave it for 1 hour. After the hour, we remove the mixture of propylene oxide and resin and replace it with 100% resin and leave it for 1 hour also. This is the infiltration step. So we put the resin on the sample to infiltrate the resin within the sample. leave the resin for 1 hour, and after 1 hour we remove this resin and replace it with fresh 100% resin again. This time we leave it overnight to make sure that our sample is completely infiltrated with resin. The next step after the overnight infiltration is to do the embedding. So for that we use what we call a bullet. This is the bullet. It's a container for our resin. So it's kind of a mold, and we put the resin inside it. We take our sample and place it within the bullet that has the resin in it. Very important to remember to label your specimen, your sample, so you won't lose it. We fill the bullet with resin, close the bullet, and it goes into an oven to be incubated overnight at a temperature of 60 degrees. Now we will place our bullets filled with resin inside the oven and leave it in the oven overnight at 60 degrees. After the overnight incubation in the oven, we will remove our sample where the resin has completely hardened. After the bullet was removed from the oven, we leave it for some time so that it comes down to room temperature. And then, using a blade, we cut off the plastic bullet to reach the hardened resin. This is how it will look like after we remove it from the bullet. It's a block with the specimen at the bottom of it. The next step is sectioning, and because we are we're preparing for electron microscopy, we need ultra thin sections, so we use the ultra microtome. We place the bullet, and first we start with the trimming of the sample, or trimming of the bullet, to reach our sample. In this case, we have done this previously. So now we have a trimmed block. Here you see the ultramicrotome, and note that because it's an ultra thin section, you have to use the lenses or through a microscope to be able to see it, to see the sample while you're cutting it. We are now starting with the sectioning. The blue container you see we call the boat, and it's filled with water so that the specimen will float in water and then can be put on the grid. In electron microscopy, we use grids, not slides. You see it now moving upward and downward. And in this case, we are sectioning our sample or cutting it. What you don't see is that it's moving also forward. So it's getting closer and closer to the knife. And in this case, we set the ultra microtome on the thickness we need. We will take one grid and take the section on it. Usually what we do before this step is we take one of the sections and check it under a light microscope to make sure that we are in the area we need. We have done that previously, and now we are taking the sample on the grid. We leave it to This is the grid as you see it under the microscope.
Yeah.
The final step is staining with uranyl acetate. We take a single drop of uranyl acetate. Then we take our sample, which is on the grid, and invert the grid on top of the uranyl acetate. Now the sample. The next step is to complete the staining with lead citrate, and for that first we add sodium hydroxide, which will prevent lead citrate from reacting. Place a drop of lead citrate. And place your grid